Sample question number 9. Actually, it has been mentioned 8, but according to the order, this question must be question number 9. So, which of the following figure represents the effect of temperature on a resistance made from aluminium? Basically, here they are asking us how the temperature and the resistors are related for aluminium. So, remember, aluminium is a conductor, isn't it? So, I can represent a temperature relation for conductor, semiconductors, and insulators. Then, how the temperature and the resistivity or resistance related for those? So let me just show you with the diagram. So it's easier for us to choose the option. If I'm representing the y-axis as the resistance, in terms of ohm, and the x-axis as the temperature in terms of degree centigrade or any other unit. So how the resistance of the conductors are related? So if I'm saying the resistors of the conductor says as the temperature increases, the resistance value increases. This is how the resistor of a conductor increases. Suppose at the 0 degree Celsius, the conductor has some resistance value, so it's that's we usually take it as r naught. And here onwards, as the temperature increases, its resistance value increases. This is how the graph of the uh, resistors and the temperature goes for the conductor. So this is what I can representing for the conductor. Any metal, it may be aluminium, it may be any other iron, it may be like any metal. This is how the resistance and the temperature related. Now why it increases? Try to understand this. Like we know that at zero temperature, every element, especially the conductors, will have they have some free electrons in it. Or at the room temperature also, I can say every conductors have some free electrons in it, and those conductors are responsible for carrying the electricity. But now what happens if you heat those conductors? What actually happens? The number of free electrons started increasing in it. So because if you heat the conductor, so whatever the electrons which were bonded with the atoms, those electron gains the thermal energy. That's like by temperature. That is what I can also say heat energy. And by gaining that one, they try to go out of their bond, and that will be like more and more free electrons available throughout the metal. And as the number of free electrons are increasing, definitely there will be the more collision it's between the electrons to its neighbor. And if there is a more collision, definitely there will be the more resistance. So more, that is how the temperature increases, the resistance of the conductor increases. But how the resistance of the insulators and the semiconductor related with the temperature? Let me show you. The resistance of the insulator and the semiconductor goes exactly opposite in it. So if I'm representing the graph, again similar graph for the temperature in terms of degree Celsius and the resistor in terms of ohm for the, let's talk about the insulator. So what we say now, let's talk about the semiconductors. Semiconductors, or I can also say insulator. This goes both insulator. As the temperature increases, the resistivity or the resistance of the semiconductor and insulator decreases. This will be the curve as the temperature increases. This curve should go in this way. Okay. So remember, here the question is about the relation between the resistor for the conductor and temperature, but you may expect a question which deals with the how the relation of the resistance and the temperature for the semiconductor relates. So this is the way they may ask it in either, and that's how do we represent the relation. So now which option is matching with our need? So that's the option C. Rather, without checking like A, B and D, I can say that C is the right answer. So what actually the B is representing? B, I can say this is the relation between the temperature and the resistor for the semiconductors, or insulators, right? So this is the relation what it's representing, insulators. And the A doesn't, C, D does not, so definitely C is the right answer. That's how do we answer to the question.